This is my favorite demo, to be honest, guys. Talking about rules and attribute rules and pop-ups and all this cool stuff. Really, just this is one of the most important thing in the utility network and the geodatabase, to be honest, right? It's just not all these features just UN, right? You can use it outside the UN as well. So how about we start with the network rules? The utility network is built on rules. You cannot just connect two lines together without having an actual rule that actually permits you to do so, right? So, and these rules are defined by the user or the whoever configures the utility network. And this is my rules. This is what I have here. There's junction head, junction. This device, capacitor of type overhead single phase must connect to an electric line medium voltage overhead single phase. You have to define this at the asset type level. So what I'm gonna do here first, because I'm gonna do some editing, I need to create a version. So I'm gonna create a version through the services, right? And we're gonna call it LTS, right? And public, change to the version, and let's switch it. And while this is switching, we're gonna zoom into an area where we can do some random edits here. And here's what I'm gonna do. I am going to create a medium voltage overhead line, 3-phase overhead line. And we'll pick some voltage here. This is, by the way, this is contingent attribute value. So because the nominal voltage knows that you picked a medium voltage, is gonna only show you medium voltages here. And if you pick a low voltage, it actually show you only the low voltage. All right, so I'm gonna create a medium voltage overhead, and then I'm gonna create right beside it, snapping to it, right? The idea of snapping, guys, this is also derived by the rule. The editor in Pro will not allow you to snap to things that are not permissible in the utility network. So I'm gonna go ahead and validate, and the validation is the process of actually persisting this stuff in the network index so we can do our cool analytics, which we'll show it at a later time. So validation says you're good because this is an overhead, this is an overhead, they can connect to each other. But I'm going to do something bad. I'm going to change the asset type of this thing to say underground 3-phase. Uh-oh, that doesn't look good. Now, if I validate, we will get yelled at. And I'm gonna just slightly make this symbology bigger so we can actually identify it. Look at that. Apply, and look at the errors we got. What are the errors we got? Hopefully I can nail it. Look at that, line error. Invalid connectivity, the edges are different subtypes and cannot connect, and that is correct. You cannot connect two edges of different subtype or asset types, right? So, guys, whoever knows something about the electric model, what do we need between these two guys? We need a riser between the overhead and the underground. And if I put that, now if I go ahead and validate that, what you're gonna notice is all the errors are gone away. And the reason is because this is a valid configuration. As long as there's a riser between the overhead and the underground, we're good, we're golden. So that is part of the rules, the network rules. Let's move on and talk about some of my favorite part, attribute rules, right? So I'm gonna go ahead and discard all my edits here. And let's go to an area where there are some services, some houses. Yeah, that looks good. And here's what I have here. I am going to do an edit to the service lines here, and you can see that every service has something called a load, and this is a voltage ampere. Okay, and when I make a change to, let's say, 150, what will happen is we will add an entry to a table called load history. And you can notice I have some entries from other tables, right? But this is my entry. I just made a change to this global ID, the service point, which is this global ID, as you can see, 40B. And now I'm gonna make another change to the same thing from 150 to 200. okay? And notice that we're also adding a log of the change of what happened exactly. Look, now we have changed it from 152 to 100. This is very cool aspects of attribute rule. So what I have done here, I wrote an attribute rule that executes on the device class. And if something has changed in the service load, I am going to insert a new load entry, right? So if I change this to 300, we will notice that there will be a new entry for the service load and so on. That is pretty cool. Let's go ahead and show you how you actually write this rule. This is the rule here. So it says this, the arcade script is, if the feature service load hasn't changed, go ahead and just exit the rule. Else, what we will do is we want to make a change to the edit to this table, the load history table, and I am going to add a new entry, and these are the attributes of the entry: the load of the change, which is service load, and what is the global ID of the feature that are being edited. Now, by just having this ability now, we can write so many cool things. Another attribute rule I wrote here is, if we have changed the service load so that it is a very big change, let's say it's changed from 300 to 900 for some reason, there's a short or this consumer has started to use a lot of load all of a sudden, I want to fail that edit, okay? And that's the rule I added here. There is a rule that says fail the edit if there's a change more than 500. So let's show you how we actually write this rule in the arcade script. So this is it. The arcade script is exactly the same, except I added this condition. If the load difference between the original feature, right, and the service load of the current change is greater than 500, I want you to exit. And this is how you essentially exit and return an error. Whatever you type in here will be displayed here. Okay, that is pretty cool, right, guys? So you can essentially fail the edit at certain condition if you are not satisfied with a certain criteria, right? And this is a new thing we added on 2.5 and 10.8 as well. So this feature allow us to get the value of the feature before it was edited, and very, very critical. You can do so much cool things with this original feature as well. All right, let's show the final attribute rule before we move in and write some arcade ourselves to actually consume whatever we're doing here, okay? Let's go ahead and save my edits because I've done a lot of cool edits here. What I'm gonna do here is, I'm gonna create a transformer bank. And this transformer bank is very interesting. I have added an attribute rule that allow me to create a transformer bank and in the process create 3 transformers with it. So, and here's what happened. One click, I created 3 features, and I also created association between those, right? So if I click this, you can see that these are actually associated with these transformers. So just one click. How did we do that? Again, the power of attribute rules. And we had this ability in Pro for the longest time, the stamp template, if you guys know about it, where you can actually stamp and create some stuff. But with attribute rule, this actually scales to the whole platform. If I edit from the web, I will get my 3 transformers with just one click, which is awesome. Okay, so now let's show how do we actually write this. Create transformer. The create transformer is some math magic here that I did. I got the geometry of the actual feature, which is the transformer bank, and I just added 10 feet to the left, 10 feet to the right, and then 10 feet to the y-axis, and that's it. So I created 3 geometries for each of the transformers I'm about to create, and I am returning the results as it is, but I am editing and I am adding features to this class, which is a transformer, the electric distribution device. Remember, we are denormalized. But if I add, I need to specify this as a group. The asset group of the transformer is 15, and the asset type of the single phase overhead is actually 522. And the phases current, because each one of them, since it's a 3-phase, each one of them will become A, this is B, and this is C. So 1 and 2 and 4 is the correspondence for A and B, C. And for each one of them, this is the geometry, this is the geometry, and this is the geometry. That's how we do attribute rules and all that stuff. And all of the attribute rules, guys, can be configured right from this menu. Okay, we can go to the attribute rules. You can configure a class and add an attribute rules and save them and change them and do all of that stuff as well. All right, guys. How about we actually write some pop-up expressions using Arcade? Let us discard all our edits and go back to the default version, and let's start making some changes here. I'm gonna make changes to this service load, make it 200, and then I'm gonna change it to 300, and then I'm gonna change it back to, let's say, 500, and then up to 900, and then going back all the way to 50. And you will now know why. Because what I'm gonna do is I am gonna author a brand new expression here that will give me the maximum load on this service. So what do we need to do? On the service point layer, I am going to create an FS history table. I'm going to read the table, feature set by name. And let's pass it the $sign data source. I mean, I'm searching my entire workspace for a table called load history. That's my table name. Okay. And what we need to do is, let's create a variable called G, and this is the $sign feature global ID. I'm gonna get the global ID of my feature, and what we're gonna do is execute a query again, the load history, where the GUID is equal my GUID, which is the service point I am clicking on. So service point GUID is equal G, and this will give me FS filter. Finally, what we want to do is return the maximum of FS filter on the field that is called service load. Let's see if this did the trick. So you know what we did, right, guys? So we did a query against the load history, which is a history of all the edits that we made. And then we, let's say, verify, looks good. And now let's go ahead and actually test this thing. And you can see the largest we did was 900. Let's give it actually a better name than custom. How about that? So I'm gonna call this max load, right? I'm gonna copy the same script, but I'm gonna create a new script called minimum load. And can you guys guess what should I change in this script? Exactly just this. And instead of saying max, I wanna do min, right? The minimum load, okay? That is awesome. And let's do another one for the average. The average load. Average. That's it. And did we name the average? No, we didn't. Let's go give it a nice name, average load. And if I click OK and then identify this guy, you will notice that we have the maximum load, which has been what, 900. The minimum load we changed it was 50, and the average is 390. So we wrote some arcade expression to actually go and fetch this information. We played with that. How about we remember our transformer? How about we actually create our transformer again? That the bank, transformer bank, because we actually didn't save. So I'm gonna go ahead and create my transformer. And that will create the 3 transformers that we talked about. And here's the rule I want to write. How about I write a pop-up that tells us how many transformers are there in the bank? How about we do that? So in the transformer bank, we will go to the transformer bank and configure a pop-up. And let's go ahead and create an expression. And my expression will be, so the function that we'll be using is called feature set by association. And feature set by association take a $sign feature, which is in this case my transformer bank that I am clicking on, and I am interested in all the content of this thing. And what we will return is immediately the count of how many associations are there. So, and we're gonna call this transformer count, right? So if I click OK, and then I go to the pop-up, click on this transformer bank, and you can see that we have 3 transformers inside this. So we learned how to use pop-ups, write feature set by name, feature set by association, and so much cool stuff.